Hello, welcome to the next episode of ML Code Mastery. So, in the previous episode, we walked through some of the steps for creating bash scripts using Python, and the goal is to create a toolbox that finally we can maybe install it by apt or different packaging systems, or maybe the PIP, something like that. And at the end, we want to use this command in every day of machine learning development. So this episode is specified for data management and data preparation. So one of the things we need to consider is to let me bring this just to show you that how process works. So in machine learning, we usually have three different steps, and I mean in machine learning development. So the first step is the data preparation, and the next step is model development, and the last one is evaluation. After that, so we need to uh, deploy it somehow or create some API for it. So I'm thinking about uh, machine learning development, not platform or not production deployment. So when we want to design a machine learning system, first we need to know the scope of the problem and downstream task we want to work on and prepare data based on that downstream task. By downstream task, I mean, for example, if we have lots of document and we want to extract some of the entities, or maybe we have some images and we want to extract some object from it. So these two have completely different downstream tasks, even though they are um, somehow working on images and extracting some information, but one of them is just extracting bounding box, another is extracting a text and part of a text. So um, there are a couple of things that still, even though the type of data and stuff like that are different, there are some sort of operation that we can make them general to be used for this pipeline. In each of these, let's see what operator do we have that we can make them generalized. For data preparation, I can say, for example, splitting data is one of the uh, important step that we always do, like using holdout. We want to separate the data to 70%, 30%, stuff like that. Or um, maybe maybe we want to do something else, like the k-fold cross validation, but we want to create those data. Um, I mean, create, for example, if we have four-fold data validation, we want to create four different folders, and in each of them we have train and test. So this is not usual, and this is not a best practice to doing that, because when we have one example of data set, so when we have this is if you consider this as a data set. So we usually, for example, in Torch, we create a data loader, and by having the data loader, we are um, if you want to apply the k-fold cross validation, so we can grab a part of it and train the model on the bigger chunk and test it on another chunk, and then change the testing chunk and training chunk until all of the data is covered. So uh, we can use it. We can use generator, for example, in Python to use to develop this. But for other splitting, like for holdout validation, that we have this data and we want to separate 30% and 70% of it as terrain and test. So maybe it's good to have a command that if we have, for example, a folder containing 100 images or containing 200 uh, text, so or documents text. So we want to split them. So let's back to the code. The split function that we want to create is somehow, it can be very complex because depends on the downstream task. Maybe we have to go through the data definition uh, or data structure format that we have. For example, if it is a segmentation and we have like label me format, so for separating or maybe Coco format, so for separating train and test, we need to go through the data and then separate that data. But um, I just want to do some simple things for now. During the time, we will improve all of these tools. For example, you see that I didn't use some of the good practices for argument for Python, but during time, we will come back to some of these and fix them based on the purposes. Okay, so let's copy and paste the OCR and change this to the name like split. So, sorry, and change this to something like split. Yeah. So this would be, we don't have any installation. I just want to have something like split, and if I apply it on a folder and I pass, for example, holdout, this is one of the methodology that we can apply, and I pass the percentage of the test, like 30%. So it will uh, separate the data randomly based on 30% of the uh, data that currently we have and put it in the folder. So we need to define the output directory, and we can say, for example, this is the output directory. So for example, we have 100 images in this folder, so we want to put them inside the output directory, and we split them to the 30% test and 70% train. This is the first use case of this one. So there are different things, like if that split is stratifying, like it's considering the label, or it's not considering the label, it is completely random. So we can pass more parameters to it. But let's do that for now. So we don't need this one. As I said, we need to define the program is split, and it is apply split on data folder. And it get, okay, for, we can get also input as parameter, so split this input, or we can say we don't need to we don't need to have it. So we can have input like this one. Input folder could be something like just like this. Or we can pass -i. And in this case, we are saying folder to apply, or directory that to apply a split. The next one, as I said, is holdout. And holdout, the default would be 30%. And or maybe because maybe in the future we want to do something else. So it should be necessary to have it. So I think there is a parameters to say required is true. So we need to pass it. Otherwise, this is uh, the thing is maybe in the future I don't want to use that. So it shouldn't be required, but the default value should be none. That if it is not defined, we say it is not defined, and we find the method. So yeah, we will fix this in the future. So for now, let's have this, and then we have the output directory or all output directory. And yeah, so this is the first part of the code that we need to do. So we get arg parser, we can print args. Now, so what we want to do now is we want to get all of the files inside this directory, and then if we search for holdout split scikit-learn, so we have examples terrain test split. But for doing that, we need to load the data. So the first thing we want to do is read all files in folder. And we can do this by list directory, and we get all of the files. Then we need to use this to split them. And there is a point here that they don't have label, or they may have label. Uh, the simple scenario is that we have a folder, and each file or folder has its own data and target. So let me explain it a little bit better. So usually when we have a data set that depends on downstream task, for example, if we have a CSV file, so we split it, and maybe, for example, the last column is the target that we want to split on. But suppose if we have two different folders, and for example, this is include images. So this one is images, and this one is the, for example, label me.json file. So label me is like, for example, any data related to annotation of that image, and these two folders are corresponding together. So we have one.jpg and we have one.json, for example, something like that. So in this case, we have images, and we can say we have target directory. If you want to do this, so we need to keep every file, if we split this and put, for example, one.jpg in train, we need to put that one.jpg in train on this directory too. So that depends a lot on downstream task. But what we can do is um, we can get the list of directory. Um, remove some of this stuff. So um, one of the things we can do is if we get another parameters like indices, so we split based on the indices, and indices can be like a list of files that we can get, or can be another input of this one. Can be another. Let's see what is the best design pattern we can think of. So first of all, let's simplify this problem. I think we cannot support like bootstrap method. We cannot support k-fold cross-validation method. We can only support simple splitting, holdout splitting. So saying that this is holdout, first of all, I don't think this is important. So we can say test instead of holdout. And we can say test percent. So this is one of the part. The second thing is that if we have a general tool, and we could be able to separate these, split these file. We could be able to use that as to split these files also, but we need some more information. So the first of all, we need to get a list of files as like metadata, something like that. And that metadata can also be input of another one. So I'm thinking that when we have these, let me give you an example. So when we have a directory, we call it data. And in here, for example, we have some, I don't know, HTML file. Okay. And we have a bunch of these HTML file. And for example, 4. So what we want to do is after applying a split on this, so we should be able to create, for example, I want to create that split directory inside and I have it like a split. So the split will be copy data, it will not move data first of all, because we don't want to move them. We want to have the main directory structure and main files. So that's why we can say we will have something like train and we will have something like test. And then in train, for example, because this is random, it will get 1 and it will get 3. And these 2 and 4 will go to the test. So we want to create something like this. But besides, we will have like meta data dot text or maybe dot YAML or anything else. I can say text for now, or maybe a JSON file. Yeah, maybe JSON is better. So it can be metadata that JSON, and that metadata include like um, these are selected as train, and we have those files, and there are some other data are selected as test. Yeah, we can have a validation option too. We can have like 2 split, 3 split. Yeah, so that's another option. Maybe we don't want to have test or train name. We want to split them based on every number they have. Like I want to split this data to 3 parts, but we don't have any uh, intersection, and also the percentage should be in, like in a list format. That also be happen. So maybe instead of having this, we can say S, and here can say S, a split, and that split is, I think, required, and the default is, and it can also be a list, so we can pass a list here, something like this. So in that case, let's forget about indices for now. So we want to create that meta JSON. In the next, when we have these kind of things, and that directory structure, I guess maybe it's better not to name it for now because we don't know if it is split to four different pieces. We don't know which one is test, which one is trend. So we can just name it 1, 2, 3. And here we can say 1, 2, and name of the files. Yeah, exactly. Name of the file like this one. Okay. And for 2 also. So this is good. So let me also change this to be 1. We can use one of them to train and test. That depends on us. And as I said, we can pass in other parameters like meta data, and we can get the metadata JSON. That would be great. This is the final thing that we want. And yeah, let's implement this. So let's have this metadata file. So this metadata file is locating metadata to a split based on that. So by that we mean go to that directory regardless of their uh, prefix, or you can say suffix, regardless of their suffix, just split them. So if you have another folder, split two, and instead of HTML we have something like JPEG, and we want to split that folder based on this folder, so we should be able to do it. Mhm. So yeah, this is what we want to build. And the usage would be when I have data and I want to split that, I can't do it just by running this line on my Linux or MacBook. So this doesn't need to be defined, and default is none. Okay, so first of all, I think if args meta, let's look at OCR example. So when we want to load one of the data, we don't need to pass it as dictionary, it's already in there. So we can say args dot meta data. So if it is not none, so we can read the, yeah, that would be good just for case. We are not implementing this part yet. So we go to the next part. If it is none, so we get the list of directory and we just show them for now. What we want to do with that, so we can split them randomly. So random, define a random variable, and actually that depends on the list. So the one of the thing is that if I say like 30%, yeah, it's this is one of the important points. So the sum of this value should be 1, everything we pass here. And I'm just wondering, can I pass a list to the Python argument? Can pass list to Python argument. So yeah, with arg parser we can pass a list. We need to say what is the type. So we can say type is float and default is what? So this is the default and type is float. So first of all, one thing that we can check is if sum args that s is not equal to 1, we need to print sum of the split should be 1 and we exit. Yeah, that's right. So now we are here, and if we have more than one, what we want to do is we have, let's back here. So we have a list of items, and we first need to shuffle them randomly because we want to, every time that we split, we want to get different result. So shuffle files. Okay, so this is cool. So we can use np.array and convert that to an array and use np shuffle files. So we get shuffled files, and we know the length of that files, or better say number of files. So what we can do with this number of files is split based on split percent. Yes, exactly. But how we know that how many split do we have? So we can say for a split index, okay, cool. So Copilot is helping us a lot. Let's see. So it said go to that and get the split index. and split. So it seems like it is getting some portion of the files, and the rest of the files would be the next. So next time it will be updated. This is nice. Then we will have joining this. So we say a split, number of a split, and we have output directory based on that. So we already had output directory. Yeah, that's why it's joining that with this. This is great. So we create that directory, and for OS, for all the file, we rename that argument with that file with this one. Yeah, it's doing most of the thing we want. Let's try it. We don't have these two directory, and we only have a split. Oh no, we only have data. So in this case, let me bring this. So if I say a split data, without anything, yeah, without anything. So the default of this would be output split. Let's see. Sorry, we should say this way. So it's a input must be a start with character dash invalid option string input. Oh, let me delete this. The following argument require dash s. Okay, let's see. If I say dash s and I say 30%, 70%, invalid float values. Let's back to this one. Number of arguments can be multiple. Oh, cool. So the thing is, we don't need to pass them in this format. We just say 30%, 70%. Yeah, cool. So let's back here. So we have output splits. We have a split 0 and a split 1. So what happened to one of the data? Uh, well, actually, it moved that. We didn't want that move. So instead of rename, we need to say copy file. And for doing that, we can use this. Let's back this file. Okay, and we remove this and run this again. So we will have a split 1, a split 0. What happened to HTML3? First of all, one of the things we forgot is instead of using that files, we should use shuffle. Or maybe instead of having that, we can say replace files with shuffle files. So in that case, every time I run this, I should see different things. Shuffled files. What is shuffle files? After applying this one to shuffle files, let me return this back. Oh, this is none. Weird. What if I print files? When I print files, this is right. Oh, it will apply it in place, so we don't need to pass anything. So let's back here. So we don't need to say that. We just shuffle it and it would be shuffle. So every time I run this, I should get different things, you see? Yeah. So that's the first thing. The next thing is, for this shuffling, do we have seed? No. But I can say np random seed. I can say args.seed. And here I can create another variable seed. Okay, and just to be sure that every time we are able to produce the previous splitting. This is also helpful. So we can say random seed for shuffling, and default would be 1, for example, and type is int. Cool. So if we have this, now let's back to the main problem, that why all of these files are not selected. Let's check another point, like if I say this, it should be some of the split should be 1. This is working also. So just fixing that and we are good, like 50-70% of it. Okay, now if we pass seed, I think seed should be always random, not random rand int between 0 and 1000. Okay. Why is always let's print seed. I don't know why this is happening. Print okay, that worked. So just changing that into the round, fix that, because if it is round, I think it's better because in other cases we are removing some of the things. If I, for example, have 4 and 6, and I remove these two, yeah, so that's somehow good. So we don't have any intersection of them. And I guess this should be false because if I have a folder, it should say file already exists. I shouldn't do it. So if I don't have it, it should do it. And it just show us what it is in output. So far so good. We need to fill the metadata. So for filling the metadata, uh, we need to have some of the information on each split. We have the split name like this. So I can say this is a split name. Cannot perform using selected element. Okay. So this would be a split name. Okay. We create metadata JSON file. So metadata JSON would be something like a split name. And we have, yeah, split files to list. This is cool. What else do we need from it? We need that metadata also can have seed, exactly. And sounds good. So we have the metadata and it should work. Let's do that. Oh, output split is, oh yeah, it is existed. So we will remove this. Let's do it again. So we have this. Now we have metadata. Metadata is split one, split one. Okay, one of the things we need to do is removing these, or yeah, maybe it's good to have it, but when we want to read it, we ignore it. Yeah. So another option we had is reading from the metadata. If we have a metadata, first of all, we need to know how many split do we have. So it's good to save that how many split we had. So here we can say metadata splits. That's cool. So let's remove this, run it again, and see the metadata. So we have a split. So when we have the metadata, the first thing first, we can go and read we don't need the pandas to be imported or, yeah, so we don't need any of this. Okay, so we can basically say args.metadata JSON load. Mhm. So that would be metadata. So the metadata split split. Now by having that split, you can say go to which split. For example, go to split 0 and grab those files, then remove their suffix, and then find that file, copy that to the directory that we want. Yeah, this is a little tricky. So we can say for item in split, we need to create something like split, and it should be enumerate on split. You can say split index. Okay, and here we say split index, get that split. So that would be a split name. Okay, for file in metadata split name, we want to copy that input file to the output file with a split name. That would be great, yes. And we want to create a new metadata. So in this case, we should say new metadata. So there is a point here that files in that directory maybe in different format, like as I said, maybe in JPEG format, maybe in other format. So the point here is if you have a file in there, remove suffix and search for the file in input. So we split it, yes. And we say for those file, okay, that would be this is not an optimized way of doing that. So I don't like to do this way. So we suppose there is only one file in that, one format in that directory. Yeah, like OS list of directory there. Where is that? Yeah, like something like this. So we need to do it. So that's why maybe it's better just to apply this at first, like here, to not do it here. So we will have files. So if we have files, um, I can change this name to something else, like input files. Okay, so if you have input files, I can get their format files. One of them should be splitted and yes, that's it. So what we want to do is we say find that file And okay, file to copy is file name plus file format. This is exactly what we are looking for. Okay, and finally it would be done. So you know what we've done is uh, we find the file name from the metadata, but the format from the directory, and we do it. So let's give you an example. So we have this directory, data1, but that data1 has text. Okay, so we want to split data. We want to split data first. Let's do that. So we have, for example, in a split 0, we have 1, 2 in a split. This is very simple, yeah. So just want to do that again to not have 1 and, yeah, that's better. No, yeah, that's better. So 1 and 3 is in one folder. We want to have the same things on that file. So what we can do, we can say data1. We don't need to pass anything. We just say metadata is inside output split metadata JSON, and the output folder would be out2. Yeah, it said it required -s. So I can remove that requirement. Here we can say if is none, split is not defined. Okay, but for this case, it should work. So it said no such file or directory. One that text. Okay, out2 split 0 1 text. There's nothing there. Should go to that. Okay, so we need to make that output directory first. And by doing this, yes, so we need to make that output directory. And for copying files, we say copy out. This is the input, yeah? So it would be the input, the data. File to copy name is right. Then copy that to this directory. Let's do that again. Okay, so let's see data. So we have 1 and 3 and 2 and 4. This is awesome. So what we've done is if we have one folder structure, we want to have that on another, so we can pass the metadata. And if we don't want to have, we can just say split and pass the data and the split values like these ones. And we can pass seeds and so on. Yeah, so what else we can do on it? Oh, one thing we forgot is metadata here. So metadata new should be saved. So we don't need to sysarg, sysexit here. Metadata new at the end of this if statement. would be metadata. Okay, so we will save seed and splits. That would be fine. So in that case, when we have arc.s, we will have an args output directory. It is same, that would be okay. We just need to add new metadata. Where is OS list? Yeah, so we can define something like this, split name, and then on every file we say append that to file to copy. So let's do that again. So if we remove out2 and we say this, so we see out2 and we see metadata, and here we go. So the seed is this one and seed is different. So that, I think that seed should be come from the previous seed. So that's why I think args.seed should also be overridden. So we should say args.seed should be override with metadata. Yes. Yeah. So just the last try. So if we have this, we say do that. The seed is this one. That seed is this one. Everything sounds perfect. Okay, hope you enjoyed the video. I will delete these data. We only have split. I will push that. I hope you enjoyed it. We will work more on things related to data preparation. So one of them is splitting. Another is like data quality check, like for images. Or another thing is resizing of images, and in the same times visualizing a plot about the analysis that we've done on resizing. Have a great time. Bye for now.